Okay, welcome to the table seating problem. Feel free to email me any questions you have if this video does not make sense. So what we have are a number of guests, and I could have named them or whatever, and their preference for which of the 5 tables that we're going to have them seated at. There are 40 guests and 5 tables, so there must be 8 guests per table. Now people say this is Madrigal, and people had a preference for a particular Juniata dignitary they wanted to sit with, then that is fine. So guest 1 here has put table 2 twice because we allow them to stack their preferences. If they really want table 2, then they can get it by putting 2, 2, and 2, or if they have 3 different tables, etc. But we're going to give them a payoff based on that. And then just if you're seated at a table in our seating matrix here, it's a 0 if you're not seated and a 1 if you're seated. So I just put 0, 1, 2, 2 so we can see if our payoff matrix is working. And so seated, we're just going to do equals sum. If these are all zeros from table 1 to table 5, then that's going to be a 0. And if they got seated at a table, it's a 1. We do this so we can have a constraint that will allow us to check to make sure everybody gets seated, and this is part of our solver. Then our payoffs are going to be, we have a simple payoff function. We're going to do equals if B2 equals 1, comma 4. Okay, so if B2 is equal to 1, if their first preference is 1, so if they got seated at 1, their payoff for table 1 would be a 4 plus if C2 equals 1, then 2, I'm just making this arbitrary, so twice as much as their first, or if table 1 was their second, then they would get, if they got seated at table 1, then their payoff would be 2, and then plus if D2 equals 1, then the payoff is going to be equal to 1. This is just arbitrary. 4, 2, 1, heaviest weighting on getting your first choice, twice as much as second, which is twice as much as third. You might have a different one. This one I just put in because it's simple and direct, and it will show the problem. So we click on this, and they end up with a payoff of 2 here for table 1. All right, so we want the B, C, and D to not move, so we're going to put $signs there. All right, and then we're going to move that across.